So 80% of the test is going to be on the board right here. And actually 100% if you include the fact that if you just study these, although I can't study it for you, that's also on there. So there's 100% of the test. Let's go over the problems, though, first, the ones that I can help you with. All right? Let's start with the metric conversions. Now, like you just saw when I passed the homework back to you, you have to show me the work. Those of you who didn't get full credit on that section. Okay? If I ask you to do those kind of problems and you just have the right answer, but you didn't show any work, you're not getting full credit. It's that simple. I made that clear when I first taught it to you. I made it clear every time I've done a problem in the back in the lab or on a worksheet, you've got to show me the work. All right, so let's show you what I mean by work yet again. On lab day, on review days, I go fast. I'm sloppy. I'm not giving notes, Roman numeral A, B, C. So you got to pay attention. You already did it. You had 20 minutes to do these problems, so you should be able to follow at that pace. Okay? What am I going to do first? Well, I'm going to erase that first. And what am I going to write down first here? Mark, what do I write down? 85.4 grams. Everybody agree? What units will go on the bottom, Karen?
Grams.
Grams. Why do they go on the bottom? You memorize the grams always go on the bottom? No. What? How do you know that without memorizing it? How do you know grams in this case have to go on the bottom? They have to cancel. They have to cancel. That's the only reason they go on the bottom. Not because, oh, I memorized it was step 1 or it was step 2. No, because they cancel. What goes on the top in this case here? Emily. This Emily.
Centigrams.
Centigrams. All right. Now comes the only thinking question. The only thinking question in this whole process. Okay? How are grams and centigrams related? And I got to give you I've given you a couple of hints about this. The first question I'd ask myself, which is bigger, a gram or a centigram? Now, most of you are thinking, I have no idea how much one weighs because I don't work with grams and centigrams every day. You're right, you don't. But you do know what centi means, and you do know what a meter stick is. This is a meter stick. These are centimeters. You know which is bigger. Which is bigger, a gram or a centigram? A gram. He will get the 1. Now, I hate to have you just memorize that. I want you to understand it makes sense that I can fit 100 of these centimeters into 1 meter stick. It does not make sense that I can fit 100 meter sticks into 1 centimeter. It doesn't make any sense. It makes sense I can fit 100 centigrams into 1 gram. Now, I am basically multiplying by 1. I'm not going to change the value of the number, just the units. Grams will cancel, and I will be left with the correct answer. I told you the only thinking step was the one we just did. Because now I no longer have to have guesswork about which way or how many places to move the decimal. I know how many places because there's 2 zeros. That's going to tell me how many places. And I know which way because the 100 is on the top. And I'm multiplying, therefore. As I multiply, it gets bigger. 8540 centigrams. Got it? Okay. Now, sometimes it may be easier to do it in more than one step, like in this case. Most of us don't know off the top of our head, unless we think about it, and most of you probably don't want to think about it, how many milliliters are in a decaliter? It's hard enough remembering just those ones I told you, kilo, hecta, deca, deci, centi, and milli. It's hard enough just remembering what they mean, 1,000, 100, 10, 10, 100, and 1,000, and which one's bigger, which one's smaller. All right, we don't want to have to go from here to here. When we did it in the old days, you probably just counted spaces. All right, I told you, if I was just teaching you a metric system, I would have let you do it again like that now. But I'm not. I'm trying to teach you this conversion factor system. Okay, so let's do this next one where we have to do 2 steps. All right, we'll write down the given 257 milliliters. Again, what units are going to go on the bottom this time? Trent? Milliliters, because this, why? You need to cancel, all right? And what units are going to go on the top? Now, you might want to say decaliters. And if you know how many milliliters are in a decaliter, fine. Do it. But most of you don't. So what would you probably go to, Jared? Liters. All right? And then I ask myself a question. How are they related? I know it's 1,000. Milli means 1,000, but where does it go? Ellie, which one gets the 1? The bottom gets the 1. 1 milliliter contains 1,000 liters.
1,000.
Right. Now, but again, here's how you ask yourself the question. You basically ask who's bigger, and it will make sense. And if you find yourself saying there are 1,000 liters in 1 milliliter, correct that. It has to be common sense. Oops. All right, so again, milliliters on the bottom, liters on the top. 1 liter contains 1,000 milliliters. Got it? Now I'm not there. It didn't ask me for liters, it asked me for decaliters, so I'll simply do another conversion. Okay? So, Zach, what units are going to go on the bottom? You.
Liters.
Liters. Milliliters have already canceled. What units are going to go on the top, Ronnie? What am I looking for? Decaliters. Right? Who's bigger? Now, this is not a common sense one. You kind of have to, this is why, even having given you this system, people will not get them all right. Because those of you who never bothered to memorize what kilo, hecto, deca, deci, centi meant before won't bother to memorize it again. There's a certain amount of memorization you can't get away from. You got to know that deca is a bigger unit and it means 10. So 1 decaliter contains 10 liters. And you have to know that. If you don't know that, you can't get it right. Okay? And so that tells you right now, if you did this without looking at your notes, this review, and you couldn't remember what deca meant, then you probably have to study that. That's an important thing. Now, once that's done, you do get partial credit. I mean, not partial credit. You do, this is all set up. This is important. This is all set up. Even if you accidentally count the wrong number of zeros or move it the wrong way, I can only take off, because I promised you I'd only take off 1 point. If this is set up properly, I can only take off 1 point for moving the decimal. But let's do it right. 1, 2, 3, 4 zeros, 4 places. Which way this time am I going to move it? Right or left? What do you think? Back up. Why? How would you remember that? You memorize whenever they're on the bottom, it's left, top right. What are you doing when you're multiplying by these guys on the bottom? You're what?
You're dividing.
Dividing. Yeah, you're dividing. And when you divide something, if I divide an apple, the pieces get smaller. So I make this guy smaller by, what did I say, 4 spaces? 0.0257 decaliters. Is that right? Good? Everybody get that? Most of you get that? Hopefully. Good. All right, let's look at the next one. Convert the following to scientific notation. 45,000. 45,000. Maddie Ice. What am I going to do? What do you have for your answer?
4.5. Zeros.
I knew it. I was hoping someone would do that. I was
It
hoping.
was wrong. It was wrong. Okay.
All right, 4.5
Times 10
times 10 to the 1, 2, 3, 4th power. Okay, so there's a couple of mistakes we can make here. That's one of them. 4.5000 isn't technically, times 10 to the 4th, isn't technically wrong. All right, it is the correct answer as far as scientific notation is concerned. What's wrong about it is you just added significant figures out of nowhere. Can't do that, okay? Now this guy has 5 significant figures when he should only have 4. All right, that's the other mistake I would have made is this. That is wrong. It's not in scientific notation. You have to have only 1 digit to its left. You understand? All right, next one. 0.0567. I want to convert him. Josh, what do you think?
5.67 times 10 to the negative second.
Times 10 to the negative what? Second. 1, 2, and it's negative second. Good. Right. And here's where, I mean, not just where, but another place you can keep in mind that what equals means. What I told you to not memorize this, but rather understand it. The reason this guy has a negative exponent is because what does a negative exponent mean? Yeah, it's going to make it smaller because 10 to the negative second is a what? It's a reciprocal of 10 to the second. It is 1 over 100. It's 1/100. Isn't that the same thing as 10 to the negative second? So if I multiply that guy by 5.67, I'm obviously going to make him back to being what he was before, right? That's the logic behind it. Okay, so you won't get him backwards. And here's the same logic here. I'm multiplying this guy by a negative 5th. Am I going to make him bigger or smaller when I do that? Smaller. So I should get is it 0.0034 or 0.0034? Which is correct? What do you think? 0.0034 is correct. Because if you kept the 0, how many significant figures are in this guy now? 3. How many were in him here? Just 2. No decimal. Okay? Yeah.
Are we doing scientific notation?
Yeah.
Oh, my fault. My bad. My bad. Let's go with scientific notation. 1, 2. This is a great one. This is one where you, again, have to use the common sense. With the instead of memorizing left, right, positive, negative, we have to remember the equal sign. I made him 3.4. And back to my other question. It's 3.4, not 3.4. Oh, chances of significant figures one. Times 10 to the what? And here's another mistake. I'm glad you corrected me on that one. By the way, that was the right answer if I were converting into standard notation, which I'm going to do next example. But for this guy, what do I have to do? I'll bet you more people have this one wrong than pretty much any other problem on here. I made him smaller by 2 spaces. 3.4 is clearly smaller than 340. So I have to make him bigger. How do I make a -5 bigger? -7? No, -3. Yeah, -3. Now I know a lot of people erase at this point because they made it -7. All right? Okay, got it? All right. Good enough. Let's go on to the next one. We're going to be converting out of scientific notation into standard notation. Okay? 4.83 to 10 to the -4th. I would hope everyone knows, oops, sorry, that is 0.000, 1, 2, 3, 4. Yeah, 3 zeros, right? 4, 8, 3. Is that right? 1, 2, 3, 4. Yeah. Right? Y'all got that? Now, by the way, that kind of a mistake, it's inevitable. Someone out of, 30 students or 50 students or whatever, I, myself, am going to eventually, if I do enough of these, miscount the zeros or miscount my places. It's not going to be a big deal. Those are the kind of mistakes we all make somewhere along the line. All right? I can't give partial credit for these kind. I can up here. You're going to miscount up here zeros. But if you have all that work shown, for those problems that are worth maybe 3 or 4 or 5 points, you'll only lose 1. All right, what about the next one over here? I got to change him to standard notation, and he's times 10 to the 5th. So I would think it's 3900. Is that right? Get that? Look good? Okay. All right, so having gotten through all this, I tried to point out most of the mistakes, even made one myself, not paying attention, and realizing this guy's I want it in scientific notation. You'll do the same on the test, guaranteed. All right, but you want to try to minimize that as much as possible, having seen it today. All right, now, next one. Now, these are the density problems. Now we'll, in some cases, just give you DM and V. I still would recommend you write it down to the side. In this case, it didn't matter, but you should write it down to the side. Because there will be, in many cases, changes to be made, changes to the units. The density in this case is unknown. The mass is 18.5 grams, and the volume is 4.789 milliliters. That's all well and good, and I don't have any changes to make. I really didn't need to write these down again. Okay? And even the equation is about as easy as it gets. The equation is D equals M over V, and I don't even have to rearrange it. It's all set up for me. All I really need to do is plug these in. But I want to see all that work, because as you'll see in the next 2 examples, I do need sometimes to do that. My mass, 18.5 grams. My volume, 4.789 milliliters, right? Get your calculator out. You do this big, long thing. You probably get a long number on your calculator screen. What is it when you round it off to the correct number of significant figures? What do you think, Nikki? 3.86. Did everybody else get that? And is that the right number of significant figures? One thing's missing. What's that? My units. Grams over milliliters. Which should make sense. Here's grams. That's not a gram. Here's grams here. Here's milliliters here. Okay? So it'd be grams over milliliters. Nothing cancels, right? Significant figures, units. And it should make sense because density is measured in grams per milliliter, right? If I were solving for volume, what should I get my answer be in? Milliliters. And if it doesn't come out in milliliters when I go to cancel, something went wrong. All right, let's try it again. Next one. How about that guy? Well, this one has more of a reason to write down the given information because everything's not going to stay the same. D equals, M equals, V equals. My D is 2.45 grams per milliliter. My mass is your unknown, and my volume is 38 deciliters. Now, I purposely added this one on here for another good conversion. Yes, I have to convert this guy out of deciliters and into the same units that are in this guy. I can't have the same quantity being measured by two different units in the same problem. So how do I convert deciliters to milliliters? I could go directly there. Most of you don't know how, so I'll have to do another double conversion. Watch this double conversion. You watching? Deciliters go on the bottom. And I can't go, most of us can't go right to milliliters, so I'll go to liters. Deci is the smaller of the dec ones, okay? So 1 liter contains 10 deciliters, right? And then, deciliters is canceled. I go from liters in the bottom to milliliters in the top. 1 is the bigger one. 1's bigger than a milliliter. A liter is bigger than a milliliter. So 1 liter contains 1,000 milliliters. And notice, in a previous one I did up here, all my zeros were on the bottom, so I moved them all in the same direction. This doesn't have to be. Here I've got 1 0 on the bottom, I've got 3 on the top, so I can just cancel them out and move them 2 spaces, bigger or smaller? Bigger, and that will make him, is that right? Everybody got that? If you forgot to do that, it's going to be points off. However, this is the beginning of the problem. This is a longer problem. It's worth more points probably than the previous problem because I had more to do in it. I had to do this. Now, it's worth more because I have more to do here. D equals M over V. I can't use it the way it is. Some of you want to just throw numbers around and start plugging into a calculator. I don't want that. I need you to show me that guy rearranged algebraically. What am I going to do to both sides to rearrange this guy algebraically, Josh?
Multiply by V.
Multiply both sides by V? That's correct. You know what I found in the other class, just the other class, the other day? People dividing by V to do this. Because they said, well, don't you have to divide? Doesn't dividing get rid of something? No, not always. It gets rid of something if it's on the top. But if it's already on the bottom, I've got to multiply by V. See it? So I get M equals V times D. And I need to see that. I want to see the algebra rearranged over there, okay? All right, what do we do next? Plug my numbers in. V is 3,800 milliliters. D is 2.45 grams per milliliter. Milliliters will cancel and leave me with what? What'd you guys get? Jared, what'd you get?
9,310 grams.
How much?
9,300.
9,300 grams. Is that right? Or did you say 10? Who said 10? 9310? Some people kept the 10. I heard it in your class too. How many significant figures are in this guy? 2, not 4. 2. How many are in this guy? 3. So if you really did get 9310, the correct answer is what? That. By the way, is it 9,300? All right, good. So there you go. Now, let's do the next problem, which I believe is percent error. It is. Okay. Now, the percent error problem here I want to do, I'll show you the mistake I see all the time. Because, it's the point of the review, to show you the mistakes you'll make. Here's the percent error formula. Don't write it outright. Don't leave it right. Percent error equals EA over accepted times 100. There are 2 big mistakes you'll make. I made one of them last period. Just like I made one this period in scientific notation. It's not impossible to do that. But this is a bigger one. Okay, I really don't want to see this. They will put 20 over 25 times 100. What's wrong with that? EA doesn't mean the observed value, does it? What does it mean?
It's the accepted minus.
It's the accepted minus the observed. It's the absolute error between these two. So my actual formula should look something like this. Absolute value of 25.0 meters minus 20.0 meters divided by the accepted value, which is 25.0 meters, and then times by 100. The other mistake I said was they write it out here, and then over here I forgot to put, I did it myself real quickly, I was doing them. On review days, I often make more mistakes because I'm doing them very quickly. I'm not just teaching you for the first time. Forgot to hit the times 100 here, okay? What do you basically get? You get 0.2 when you do that, I believe, right? 0.2 times 100 would be 20, correct? But the question is significant figures. What should it be for significant figures? How do I show it? 20.0%. By the way, it's 100%. Well, first of all, meters cancel for units. That's correct. And then 20.0%. Okay? There's 3 significant figures for each of those. Of course, if you kept this one, it would be 5.0, and that only has 2. But anyway, I don't care either way about that one. But before you go, real quickly, significant figures in the following problems. How many? 3, because you start from this side. And here, 2, and here, 3. Study these terms, and you're done. Okay?